if we look at a function and its inverse, and we look at the graphs of them, we're going to notice some kind of similarities between them. So if we look at y equals x squared plus 4, and then the inverse of that, which would be y equals plus or minus radical x minus 4. Okay, so if we just plugged in the x and the y, we've switched them to find the inverse, we'd end up with this. Now we know that the inverse here is not going to be a function because of that plus or minus. But let's just look at what these graphs look like. So for the x squared plus 4 function, if I just pick values for x, so if I plug in 0 for x, I'm going to get 4 for y. If I plug a 1 in for x, I'm going to get 5. If I plug a negative 1 for x, I'm also going to get 5. If I plug in 2, I'm going to get 8. And negative 2, I'm going to get 8. So here, none of the x's are repeating. If I flip my points to get my inverse, I have 4, 0, I have 5, 1, I have 5, negative 1, I have 8, 2, and 8, negative 2. So right there, the x's are repeating. So we know that that's not going to be a function. So if we look at this, the original, I'm going to graph that. 1, 0, whoops. Original was red. So I'm going to get to 0, 1, 5, negative 1, 5, 2, 8, negative 2, 8. So this red function, oops, not the prettiest, but okay, that's x squared plus 4. So we know that the vertical line test can tell us if this is a function or not. So if I drew vertical lines through this, I know that it's only going to cross at one point each time, so that is a function. If I graph the other one, if I do the vertical line test on that, it's going to fail it because it's going through 2 points at the same time. So if we looked at the red function, I can only look at that one and be able to tell if the inverse is also a function by using the horizontal line test. So the vertical line test, that's going to tell me if that function, if that graph is a function. So for example, function question mark. So is the original a function? I can use the vertical line test. If I use the horizontal line test on the original function, or the original graph, excuse me, that's going to tell me if the inverse is a function. So if I were to draw horizontal lines along the red one, horizontal is going this way, it's failing the horizontal line test because it's passing through 2 points at the same line. So the vertical line test is going to check if the original graph is a function. The horizontal line test is going to check whether the inverse of that graph will be a function or not. So we don't have to necessarily graph the inverse function. Now, there's a thing called a one-to-one function. So for a function to produce an inverse that's also a function, it must be one-to-one. So, for example, this one, clearly, the inverse is not a function, so this is not a one-to-one. But I can make this become a one-to-one function. So a one-to-one means that the x's and the y's are both not repeating. So when we flip the original function to find the inverse, the range is becoming the domain is becoming the range, the x's and the y's are all flipping. So if the original function has repeating y values, that means that the inverse will have repeating x values. Okay, so one-to-one functions, everything is separate. There's no repeating x's, there's no repeating y's. Okay, so when you don't have a one-to-one function, you can restrict the domain to make it a one-to-one function. So if we look at this example that we had here, I know that the inverse is not a function because I have 2 pieces. So if I just get rid of a piece of it, if I get rid of this piece, let's say, and I change the function from being plus or minus to just the positive version, that's what that graph looks like. Okay, so instead of taking plus or minus, if you just take the positive version, that's going to match up with just the positive version of the original graph. So I would have to also get rid of this piece. Okay, so now this is a one-to-one function, and we're going to restrict the domain. And I'm going to tell you what I mean with that. Okay, so for each function, find the domain and the range, and then we want to find the inverse and determine if it is a function. And if it's not, we want to restrict the domain to ensure that the inverse is a function. Okay, so really this is only going to happen if your original function is a quadratic. So when you have x squared in your original function, the inverse will not be a function every time because you take the square root and it's plus or minus. So for those problems only is when we have to restrict this. So if we look at the original here, I know that the domain on this is going to be all real numbers because it's a quadratic. The range, this is in vertex form. So I know that the vertex is going to be, I'm going to write this up top. The vertex is going to be negative 2, 1. And I know that because of vertex form. And the a value here is positive, so this is going to open up. So since it opens up, my range is going to be greater than or equal to 1. So this is my original. So now we want to find the inverse. So just like what we did before, we're going to switch the x's and the y's. So instead of f of x, which is really a y, I'm going to make that x, and I'm going to change this x to a y. Okay, so I want to subtract the 1. So again, I'm just going to flip the order of this. So when I subtract the 1, I have x minus 1, and then I'm going to take the square root of each side. So now I have y plus 2 equals plus or minus radical x minus 1. So the last step, we want to subtract the 2. So we end up with y equals negative 2 plus or minus radical x minus 1. So that would be my inverse. But right now, this is not a function because I have that plus or minus. Okay, so we determined that it's not a function. So what we can do is restrict the domain. So instead of plus or minus, we're just going to take the positive version of it. So the inverse, which is denoted by f to the negative 1 of x. Okay, don't get confused with that. It doesn't mean you have a negative exponent and it goes to the bottom. This is just the notation for inverse. So the inverse function is going to be negative 2 plus radical x minus 1. So all we did was we took away the plus or minus and we just made it plus. So this is our inverse. And now this is a function because it's only the top piece of that little hook. So the domain of this, it's a radical function. So I take the radicand, the x minus 1, and I make it greater than or equal to 0. So the domain is going to be x is greater than or equal to 1. If I plug that in, what's in front of the radical is still a positive. So even though there's a negative 2, the negative 2 is not in front of the radical itself. So the radical function is still going to be facing up. So if I plug in, it's going to be greater than or equal to negative 2. So this is my domain and my range. So when I have a function and I have an inverse of that function, the domains and the ranges are switching. So in the original, the domain was all real numbers. But we restricted it because our range is not all real numbers in the new function, the inverse. Okay, the range of the original function, y is greater than or equal to 1, becomes the domain of the inverse. So basically what we did here is we're restricting this domain. So this one here, instead of being all real numbers, we're going to restrict it. And it's going to be what the range is of the inverse. So it's going to be x greater than or equal to negative 2. So we're just restricting the domain. Okay, let's look at this other example. Okay, so first step, find domain and range of the original. So the domain will be all real numbers because it's a quadratic. And this is in vertex form again. So 7, 0 is our vertex. It opens up, so y is greater than or equal to 0. Now we want to find the inverse. So we're going to switch the x's and the y's. So x equals y minus 7 squared. And we're going to take the square root of each side. So y minus 7 equals plus or minus radical x. So y equals 7 plus or minus radical x. Okay, because we have plus or minus, this is not a function. So we're going to get rid of the minus part of it, and we're going to say that the inverse function is going to be 7 plus radical x. So we're going to restrict that domain to make it just the positive version. So the domain of this would be x equals to 0 since it's a radical. If I plug in 0, I'm going to get 7, and I know that this opens up since it's positive in front of the radical. So y is greater than or equal to 7. So remember, the domain and range is going to be flipped from the original and the inverse. So the domain of the inverse is x is greater than or equal to 0, which matches the range of the original. Because we had to restrict the domain, we're getting rid of all real numbers for this domain, and we're going to restrict it. And when we restrict it, it's going to be equal to the range of the other x. So x